So here we are, Unit 5 at Part A continued. Let's see, in our last lesson, we looked at fundamental identities and used them to find values. Now this was a different way of finding, right? We had to use identities. We know other ways to find a trig value, but for this unit, we're going to use identities. We didn't do much with cofunctions yet. That's coming up. So here are the identities, the reciprocal and the quotient. You need to remember these. 6 plus 2 is 8. The unit circle, you're going to be allowed to use the unit circle when you actually have to determine the value. So you may not be using your calculator, but you'll be using your unit circle, and you will have memorized, get that word? Memorized the fundamental identities. Add the Pythagorean to those, and the only one you actually need to memorize is this one, because as long as you know this one, it's easy enough to derive this one and this one. How do you derive this one? You divide everything through by sine squared theta. How do you derive this one? You divide everything, just the opposite, isn't it? For this one, if you divide everything through by sine squared theta, you get this identity. If you divide everything through by cosine squared theta, you get this identity. Here's the general strategy for proving an identity. You work with only one side of the equation. You sequence through, making sure that it's evident that what you do in each step relates to the step before. So in this one, in order for this to be evident to the reader, you have to recognize that a difference of squares will factor into conjugates. A difference of squares will factor into conjugates. And then, in the next step, we recognize that these, the denominator and this factor in the numerator, can be seen as a fancy 1, so you can cancel it out, get this, and then you remove those parentheses, and you end up with what you were headed to. Now remember, the other side you don't touch. You just keep working with this one until it is exactly the same as the other. Then you are complete. Now here are some hints. You begin with a more complicated expression, so make that the one that you work with. If you don't know where to go with that, translate everything into sine and cosine. It can always be done. When you have fractions, combine them over a common denominator. Remember that conjugates multiplied together will give you a difference of squares, and when you look at the Pythagorean identities, we don't see any difference of squares here, do we? But they're very often showing up as a difference of squares. You may see 1 minus sine squared theta equals cosine squared theta. Or similarly with these can be written as equivalent identities where you actually have a difference of squares. So that particular algebraic knowledge can be very helpful. Keep in mind where you're headed. That will sometimes inform you in what you're going to do next. Do not expect to see the path ahead of you clearly from the start. If you expect that, you're going to be so frustrated. Just get going and try things. If you are not making much progress, one thing you can do is work from both sides. So ordinarily we say, okay, we'll work with this one until we get it to look like this one. Well, I think we did practice this. You could work down until you find something that is common here. So keep going until you get something that they share, and then you can link them in this way and go back in the opposite direction. Here are some trig identities for us to work on. I'm going to just do one. I'm going to keep this lesson really short. I'm just going to do one, and then we'll see how you fare with the others back in class. So let's demonstrate this. I think I'll work on this side. And I want to get over, this is adding a negative, and this is multiplying. So I think I'll start with just translating these into sine and cosine. So this would be, secant, when I translate that, would be 1 over cosine x minus cosine x. And I want to have a common denominator. So what I'll do is I'll multiply this one by a fancy one, cosine x. Be nice if you could read it, huh? Sorry about that. Gee, I think I'm going to have to rearrange things a little bit here. All right, so this will give me everything over cosine x. And this will become 1 minus cosine squared x. And what is that equal to? If we use the Pythagorean theorem, didn't we just look at that? Well, no, we looked at the other one. I could have as easily here said 1 minus cosine squared theta equals sine squared theta. And isn't this the expression that I just came to? Yes. So that's going to be sine squared x over cosine x, which I recognize could be written as sine x times sine x over cosine x, which could be written as sine x times tangent x. I'm done. It's good. 10 minutes. See you back in class.